Physics works beautifully inside our everyday world. Planets orbit, light travels straight, and time moves forward at a steady pace. But as we explore deeper into the universe, this certainty begins to crack. There are regions where equations stop agreeing and reality behaves in ways that appear impossible. Scientists call this the edge of known physics, a boundary where our understanding fades and nature refuses to follow familiar rules anymore. One such boundary exists near black holes, close to the event horizon. Gravity bends space so severely that distance itself changes meaning. Two observers may disagree about how far apart objects are. Light curves back toward its source, and clocks tick at dramatically different speeds. For someone falling inward, time feels normal. For a distant observer, the same moment stretches forever. Reality splits depending on perspective. At even smaller scales, quantum mechanics creates a different kind of confusion. Particles exist in multiple states at once until measured. They pass through barriers without crossing them and appear linked across enormous distances instantly. Cause and effect blur together. The universe does not choose a definite state until interaction forces it to. Reality becomes probabilistic instead of certain. These two theories, relativity and quantum physics, both work perfectly in their own domains. Yet when combined, they contradict each other. At extremely dense points, like the center of a black hole, equations predict infinities. Density becomes endless, volume becomes zero, and mathematics collapses. Infinity is not a real physical value, meaning our theories are incomplete at this boundary. The Big Bang represents another edge of reality. If we rewind cosmic history, temperature and density rise without limit. At the first instant, known physics cannot describe what existed. Space and time themselves may have emerged from something deeper. Asking what came before could be meaningless because before might not have existed at all. Even space is uncertain at the smallest scales. Quantum fluctuations constantly create and destroy tiny particles in empty vacuum. Space is not smooth but foamy, vibrating unpredictably. Distance is smaller than the Planck length cannot be measured because measurement itself disturbs reality too strongly. The fabric of existence loses continuity. Some theories suggest multiple dimensions hidden from perception. These dimensions could shape gravity's weakness and unify physical forces, but they remain invisible because they are tightly curled smaller than atoms. Our universe might be only a surface embedded in a higher dimensional structure we cannot directly observe. Cosmic expansion introduces another mystery. Galaxies move apart faster than light across vast distances. This does not break relativity because space itself expands. Yet beyond a certain horizon, regions become permanently unreachable. Information from them can never arrive, effectively removing parts of reality from observation forever. Dark matter and dark energy deepen the confusion. They dominate the universe's mass and behavior, yet remain undetected directly. We observe their effects but not their nature. Most of existence is made of something fundamentally unknown, meaning our familiar matter represents only a small fraction of reality. At the quantum level, time may not be continuous. Some models describe it as discrete steps rather than smooth flow. If true, the present moment cannot be divided infinitely. Reality would update frame by frame, like a cosmic simulation running at unimaginable speed. Information paradoxes also challenge logic. When black holes evaporate, the information of swallowed matter seems lost. But physics forbids true destruction of information. Resolving this contradiction requires new principles beyond current theories, hinting our understanding of causality is incomplete. Observers themselves affect reality. Measurement collapses quantum possibilities into definite outcomes. This suggests observation is not passive but part of physical law. The universe may not have fixed properties until interaction occurs. Some physicists propose reality emerges from information. Space, time, and matter could be secondary effects of deeper mathematical relationships. Instead of objects existing within space, space might arise from connections between objects. Near the cosmic edge, prediction fails completely. Tiny fluctuations determine large outcomes. Determinism fades, replaced by probability. The universe becomes less like a machine and more like a constantly resolving equation. Every new discovery pushes the boundary outward but never removes it. Each solved mystery reveals a deeper unknown beneath. The edge of reality is not a location, but a moving frontier of knowledge. Where the universe stops making sense is exactly where science advances fastest. Confusion signals discovery. Beyond that edge lies a deeper theory waiting to connect everything, gravity, quantum physics, and existence itself into a single coherent picture.